and girls, it's Know It Time! Know It Time!
Let's get crack-lacking. Here we go. Today, I want to show you how to solve... I'm going to show you how to solve radicals. I'm going to give you an example. Last time, I taught you how to... last time. I'm just going to write a few things down. Last time, I taught you how to graph radicals. And that was a really simple process. Nothing too bad. Okay. But today, we're going to actually solve it using algebra. So I'm going to give you simple question. And we'll just work on this. Let's say I have an equation. Square root of x plus 5 minus 3 equals to 0. This is actually grade 11 stuff. I'm going to pause it without any help from me, and I want to ask you to solve it. Let's see if you can solve it. Let's start today with, who haven't I ever picked on first before? Devesh, haven't picked on you first before. Well, give me an answer. 4? So you have x equals to 4. Vicky, do you have an answer? 4. So majority of you are saying 4. But here's what you should always do first. Write this down, star. Before solving any radical, you must find the domain. So before you solve any radical, what you gotta actually do is find the domain. This is the key. So I'm gonna pause my recording. Okay. Deep, what's your domain gonna be? Sorry? It's correct. I want to highlight this part right now. This is the radicand. And I've taught you before, the radicand cannot equal to 0 or less than 0. So x plus 5 has to be greater than or equal to 0, and I solve it. Which means this. Oh, there's a negative here. Whatever my answer is, it better be greater than -5 or equal to -5. If I have an x value that is, let's say, -6, it doesn't work. So this is the first thing you always do. Now, here comes the fun part. When you have a square root, Devesh, what was the first thing you did? Take the -3 other side. In grade 11, you were taught to get the square root by itself. So now you have x plus 5 equals to 3. Okay. To get rid of square root, we squared both sides. So that's a squared. Nothing hard, nothing tricky. X plus 5 equals to 9. And you're absolutely correct. The answer is indeed 4. Okay. No tricks, no nothing. And again, compare. Say, look at my domain. This falls in the domain, so it works. Falls in the domain. But some people are visual learners. They say, it's too hard. I'm going to use my TI-83. I'm going to ask you to do the second method. 2. Solve graphically, which means use a TI-83, which means I don't need to use anything but my calculator. Without any help, I'm going to write down my original question again. Root x plus 5. Oop, come on. Oop. There's... Okay. So my original question was square root x plus 5. My computer is really slow today. X plus 5 minus 3 equals to 0. I'm going to pause it and let you... So if I was to solve it graphically, let's grab my TI-83 out. Okay. First thing, I clear all this stuff out, and I was going to square root x plus 5 and brackets minus 3, and I hit graph. If you did it correct, your graph looks like this, and there's 1 0 here. And what they really want to know is, what is that 0? I go second, calculate, I go to 0. Or you can do table. And you go enter for left bound. I go slightly to the right of it. There we go, slightly to right, hit enter. One more time. And notice it says x equals to 4 right off the bat. That's called solving graphically. On the exam, you expect to do two methods, algebraically and graphically. Try another one. A bit more challenging, too easy. What if I give you this one? Square root. So you're going to do two methods, starting with algebraically first. X plus 5. This time I'm going to add in one more thing to make your life a bit more challenging. X plus 3. I'm going to ask you to solve it two ways. One, algebraically. Once you finish it algebraically, I want you to look at it graphically. Compare the two answers. They should be exactly the same. If they're different, one of your work is wrong. Starting with algebra. I'm going to pause it and let you know. I'm going to work with algebraically first. And the first thing I noticed was a lot of students, they did this. They go square root and they square both sides, which is perfectly correct. Okay? So I'm going to square both sides. But before I actually do squaring, I should always do something first. I need to find the domain. Okay? Now the domain really is only this part for this stuff. So Manraj, what's your domain going to be? X is greater or equal to -5. That's my domain. So now, what I'm going to do is I square root both sides. I have x plus 5. Be careful when you square root the right side. Pindu, when you square the right side, what do you get? Good. A lot of you forgot the 6x. Now I bring everything to one side and I equate it to 0 because that's a key. So it'll be x squared plus 5x plus 4 gives you x plus 1, x plus 4, x equals to -1 and -4. And you check with your domain and say, hey, high five, it works. But I want you to solve it graphically and you realize something. Okay, let's solve it graphically. So let's do this graphically. Because I say we're going to do both and your answer should match up perfectly. So when I solve it graphically, there's something happens to this one. So it'll be x plus 5 minus x minus 3. And I hit graph. When I do this, notice it only shows one answer. And that answer is at -1. The question is, what happened to -4? I'm going to pause it. I'm going to show you what happened to -4. The reason what happened to -4 is this. Write this down, star. This is crucial. Plug your answer back in. Okay. To the original question. This is actually the final step. It passes my domain test, but now when I plug it back in, and we'll see what happened to the original question. Okay. Now here's where your calculator is kind of stupid. I'm going to kid you not, your calculator is actually kind of stupid. Your calculator only assumes one thing. Treat in this unit, note I'm going to write in this red, in this unit only. Treat radicals as positive. Normally when I treat a radical, I train you to think as positive, negative. But this chapter, your calculator, because they want to match it up with your calculator only works in positive mode. So we're going to treat this as only positive square roots. So I'm going to go back and plug it in. So you go root x plus 5 equals to x plus 3. I want you to plug in -1 first, right now. Okay, go ahead. So plug in -1. So you go square root negative 1 plus 5 equals to negative 1 plus 3. On the right hand side, you have 2. On the left hand side, you have square root of 4. And look at this. I'm going to write this in a different color. This is important. Notice I'm using only the positive form because they want to match it up with your calculator. When you graph in your calculator only works in positive mode. So that works out. I want you to test out negative 4 and see what happens. I'm going to pause it and let you. What happens when I plug in negative 4? I go square root. Negative 4 plus 5 equals to negative 4 plus 3. On the right hand side, I have negative 1. But on the left hand side, I have positive 1 because my calculator only works in positive mode. That's why when you punch in square root of 4, every calculator has 2, never negative 2. So this number is actually a reject. And I need you to write this as reject. Okay. The reason why is only in this unit is when you treat it as a positive because they want to make sure it's the same. One last question, and then I'm probably going to give you the supernode question for today. Okay. Very simple. You're going to do this 2 forms again. Solve algebraically and graphically. You choose which one you want to do first. I'm not going to tell you. So I'm going to have square root 3x squared minus 5 equals to x plus 4. Again, I'm going to pause it. I'm going to show you the first few lines in case you're lost. A lot of you decided to do algebra. So I'm going to just follow in your footsteps in the algebra. Squared, squared. The left-hand side is easy. 3x squared minus 5. The right-hand side is x squared plus, does anyone, if you were in my class in grade 11, I taught you a shortcut, how to go from here to here just by looking at it. Does anyone remember the shortcut? Because you're going to need a shortcut soon. Most of you expanded a long way, but there's actually a shortcut. In universities, they expect you to use a shortcut. Curleen, what's the shortcut? I squared both sides first. That's where x squared came from. Then how do you get the middle piece? To get the middle piece, you take the 2 times the 4 times the x. That always works. You're going to save yourself a lot of time in the future. How many of you were taught that technique in grade 11? 1, 2, 3. Good, because you need that technique. Because later on, you're going to get something like this. For example, 3x minus 2y. I want you to expand this out using the shortcut technique right now as a practice. You should know the answer just by looking at it. We don't need to FOIL. That's grade 9 stuff. Angelica, what's the first term? Ooh, not 6x squared. Close. 9x squared. Amrit, what's the last term? Oh, whoa, 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 whoa. Positive 4, what? Y, what? Squared. See, I'm missing the middle term. Sigmund, what's the middle term? This is a tough one. I take 2, 12, actually you're correct, negative 12, what? Both x and y, yeah, that's it. I take 2 times negative 2y is negative 4y. Negative 4y, and that's a shortcut technique. So now, why don't I move things over and solve it? So I have 2x squared. Okay. Again, I keep it simple. This is going to be minus 8x. This is going to be minus 21 equals to 0. The fun part begins. I'm going to pause it again. And at this point, most of you use quadratic formula, which is correct. You should have 8 plus minus 8 squared minus 4 times 2 times negative 21 all over 4. And I'm going to quickly do this calculation in my head. You should have 5.8 and negative 1.8. I'm going to graph it now because I want to see it graphically. My graph should match up exactly with those 2 points. Exactly. So let's graph this right now and we're going to see if it works. Okay. I go square root 3x squared minus 5 and bracket. Make sure you have brackets. A lot of people screw up when they don't have brackets. Minus x minus 4. And I hit graph. And your graph is going to be pretty funky. One looks like that, and one looks like that. Some of you will ask me, why is the graph look so weird? Here's the reason why. Because if I look at this, I know this is a parabola, 3x squared. I'm just going to draw, just pretend this is the graph. Okay? I know it's not the graph, but just pretend. So I taught you yesterday, remember how to do the square root of this graph. The square root of this graph will have two pieces. And that's why there's actually two pieces. Exactly what you did yesterday. So now, if you use the zero function key on this TI-83, you will get exactly negative 1.8 and 5.8. Try it right now if you don't believe me, but that is your answer.